Now we are discussing the comparison of four Thyristor family devices. One is silicon unidirectional switch, second one is silicon bidirectional switch, third one is silicon controlled switch, fourth one is light activated silicon controlled rectifier. All of these Thyristor family devices except SCS, they have three terminals. Speciality of SCS is it has two gates, one gate at anode, one gate at cathode. That's why terminals for SCS are 4. Remaining all have terminals only 3, anode, cathode, gate. Switching type, all are unidirectional except SBS. It is bidirectional. We can turn it on from both the ways. That's why for the remaining devices we have anode and cathode, but for SBS we have T1 and T2. If the current is in this direction, this is anode, this is cathode. If the current is in this direction, this is anode and this is cathode. Cost. There is no special arrangement required for these two, cost is less. Special arrangement is required because we are adding gate at anode, cost is high. And here special arrangement is required because gate current is due to light activated SCR. These two devices are high cost compared to these two. Turn on or off. All the devices except SCS, they work with the positive turn on mechanism, but this SCS, by giving the positive signal, we can turn off the SCS. This is the speciality because we are using two gates, one at anode and one at cathode. Okay, right, next. Triggering mechanism. All the devices, because gate is the triggering device. By using the gate, we turn on the SCR. That does not mean there is no supply required at anode to cathode. We have to give anode to cathode supply, but instead of 200 volts, if we want to turn it at 30 or 40 volts, then we have to give the gate current. All these three devices, the triggering mechanism is due to gate, but here the triggering is due to light. Next, power handling. These two devices, less power only required. They handle very low powers, and current bill also due to these two devices is very less. But here we are handling two gates, power is medium, power handling capability. They can handle the high powers, very high powers. How, sir? Because light, even if you give very high voltage between anode and cathode, if the light does not fall on the gate, it will not turn on. So very high power handling capability. Applications. Because this LASCR can handle the high power, we use it in high voltage DC transmission systems, where we use, example in railway lines, we use the high voltage DC transmission systems. And for low power circuits, we use the SCS for low power circuits. Because we have to turn off, we can turn off with the gate signal here. That's why we are using here. Next, for the fast switching applications, SUS is better. And for high speed applications, both SUS and SBS can be useful. Particularly when you want to use the pulse generator can be manufactured by using the SUS, pulses if you want to generate. These are the circuit symbols for the four devices. Okay, once again we are revising. Now tell which device is having 4 terminals. Why? 2 gates. Remaining all have? Now which is bidirectional device? Very good. Why the stability of SCS is low? Very good. LASCR is low. Very good. Why the cost is increasing for SCS and LASCR? Because of two gates, and here a special equipment is required to make sure that light falls exactly on the junction. Triggering mechanism. Triggering mechanism in which device is due to light? Power handling capability is high where? Very good. Where we can use, which device we can use for the low power circuits? Okay.